So Jeff is an assistant professor of computer science at Stanford University, where his research focuses on human-computer interaction, interactive visualization, and social computing. His work has produced novel visualization techniques for exploring data, software tools that simplify visualization, creation, and customization, and collaborative analysis systems that leverage the insights of multiple analysts. He is the author of the open source visualization toolkits Preface and Flair, currently in use by the visualization research community and numerous corporations. Over the years, he's worked at several great places, including here at Xerox PARC, IBM Research, Microsoft Research, and Tableau Software. He holds a bachelor's, master's, and PhD degrees in computer science from Cal. Go Bears.
Yeah, so thank you. So yeah, my name is Jeff Heer, and I did spend 10 years at Berkeley, and I've been at Stanford for just about 2, which I've learned is just almost enough time to get over the cognitive dissonance of betraying one's alma mater. But fortunately, that blow has been softened. I work with a number of great folks at Stanford, including wonderful students and great colleagues, including Terry Winograd and Scott Clemmer in HCI, and I also co-lead a visualization research group with Pat Hanrahan, and it's some of that research I'd like to share with you today. So I thought I would start with a question. How much data in bytes do you think that we as human society produced in 2010? So too much is a good answer. If we spend time on YouTube, that might lead you to that conclusion. Anyone want to wager a guess? Yes, in the back. So uniquely, so uniquely created. So distribution will up it by a couple orders of magnitude. Okay, so above petabytes. Anyone just throw out some numbers?
25,000 exabytes.
What's that?
3,000 exabytes.
3,000 exabytes. Wow, that's the biggest one I've gotten. Anyone know what that means? So yeah, if we were playing The Price is Right, I'm sorry you've lost because you went over. But no, it's 1,200 exabytes, so that's a lot. What does that mean? So if you look at the textual holdings of the Library of Congress, this is over 60 million times more data. But as we all know, if you've taken mathematics, computer science courses, we know the absolute numbers may be less interesting than the rate of change. How is this changing over time? Well, that was a 10x increase over the last 5 years. So you're really looking at this amazing accelerating growth curve in terms of data production. And if you look at, I'm sure there's some creep due to evolution of our cognitive and perceptual capacities for handling this information, but I think you agree that our sort of evolved capabilities may be being dwarfed here. And so there's a lot of questions about, well, where is this data coming from? And that's coming obviously from physical sensors, from collection of data of various types. But I think a lot of it's also, and this has been documented, comes from our own personal activities as well. So all the things that we're doing on the web, the transactions that we're engaged in, the people we're meeting, those exchanges are all contributing to this massive amount of data. And I think it's interesting that a lot of this data is about human activity because it means if we can gain more insight into this information, it may help inform our decisions about how to improve governance, education, business, and perhaps even our personal lives. And so I think this is a really interesting opportunity, and so that's one of the reasons that I've been warmed to this quote from Hal Varian, Google's chief economist, who said, "The ability to take data, to be able to understand it, to process it, extract value from it, visualize it, communicate it, that's going to be a hugely important skill in the next decades. Because now we really do have essentially free and ubiquitous data, so the complementary scarce factor is the ability to understand that data and extract value from it." And I don't think this is a new theme, but I think it's a critical one that's just continuing to gain importance in our society. And so the focus of the research that I do is to find ways to help reach these goals, to help us understand data and extract value from it. Now, one of the primary ways we do that is through interactive visualization. We want to create visual representations, leverage sort of our perceptual capabilities to help us more quickly recognize patterns, make inferences about data, and one means of helping combat information overload. But the fact that we're named the visualization group, I have to say, is actually a bit of a misnomer because we're not interested in visualization for its own sake. What we really care about is the life cycle of data. What is the process of analysis? And visualization is really just one component in understanding that, as where does data come from? Who generates it? How do we acquire it? Do we have to clean it up, integrate different data sets, engage in analysis, create presentations, communicate and disseminate our ideas to others? And I think while many of these have been touched somewhat in the HCI community, but also in other communities such as statistics, databases, and machine learning, there remain huge challenges on how to design appropriate user interfaces to deal with these tasks. And while it may be convenient to think of the process as something as a waterfall, and in fact many tools are designed with this notion in mind, I think anyone who's actually dealt with data analysis in this audience, which I imagine is most of you, knows that the real-world process looks much more like this. Where, of course, you find data, you visualize it just to realize your data is awful, right? There's problems, it's dirty, there's missing data, et cetera. Or you formulate a presentation, and it's only when others see it and provide feedback do you realize maybe you missed an important question that you should have asked in your data. So how can user interface design help us better master this analytic life cycle? So what I wanted to do today is just share with you a handful of projects coming out of my lab where we're trying to address at least some of the bottlenecks we've identified in this process. So I'd like to start with an example kind of earlier in this life cycle, and that's the problem of data cleaning, which many of you have had to do it know it's incredibly annoying and also perhaps very tedious and also critical to making proper inferences from data. So let's think about ways visualization and user interfaces might help with this problem. So to do this, we built a system called Data Wrangler. This is primarily the work of my student, Sean Kendall, along with a number of collaborators. And so what I thought I'd do is just jump right into a demo to give you a sense of what we're trying to do. So this is the landing page for the site. If you want to play along in real time, this URL is live and accurate. And what you're seeing here in this box, let's just say I've copied and pasted this in here. This is data taken from the US government, and particularly the Bureau of Justice has different statistics. And this is housing crime data for different states and different years. And you might have noticed it's come in a somewhat funky format. So we have different submatrices, as it were, for each state. And this looks sort of like normal CSV, that's comma separated values formatting. But then we have these weird title rows with the state name embedded in there. And so as any of you know, if you try to load this directly into an SQL database or a visualization framework, it just breaks. Right, and this is actually a huge hurdle from people who are very savvy and can work with data, but the problems like this get in their way from actually realizing the value of that data. So let's see what we can do. So in this case, I'll click the Wrangle button, and this loads the data into, in this case, a tabular format. We're able to do a couple things right off the bat. I mean, there's some very common formats, so we're able to automatically split the data into rows by new lines and split into columns by commas. But we're still left basically with this dirty data. And so let's see what we might do. So the design philosophy here is that we want to have the human engage in a conversation with the system in order to clean up data. So in this case, I might indicate the piece of the data I might want to manipulate. So here's an empty row, and if I click it, as I do this, you'll see that a number of suggestions are provided in terms of what I might do with that row. The simplest thing is I click the row, I might delete it. But in this case, it saw that the row is empty, so it infers some other possibilities, which then I can page through. So in this case, the next one says delete empty rows. And you see that I'm providing visual feedback to try and give a summary of what is the outcome of this particular transformation. This is a fairly simple one. We just do red highlights to indicate delete. In this case, I hit enter, and now I've gotten rid of all those empty rows. So I've taken one step further into getting clean data. But I still have this annoying artifact. Here, the state name is buried in the string. So let's tell the system that I'd like to do something with that. So I grab that in Alabama. And so by selection, it automatically thinks, well, OK, I'm trying to do an extraction. I could also be trying to delete that text, and there's options for that. You see these cut options down below. But it's kind of made a wrong guess. So the natural first thing to do is assume I'm selecting a string based on indices. So in this case, between position 18 and 25. And of course, we lose the S in Arkansas. And because Alaska is shorter than the string, it gets left out entirely. So what we do instead is just provide more examples. This is like a classic example of programming by demonstration. In this case, by providing another example, it's able to infer a different extraction pattern. In this case, move out the text that comes after the string in space. And I can see visually here that this is what I want, so I hit OK. Of course, now I have these states where I'd like them almost. I have all this empty rows. And so you might have noticed these bars above the top. So these are actually data quality meters. And so what it's done is looked at this column, for example, and see that most of the values are numbers. So that actually corresponds to the green here. And there's a little number icon to show the type it inferred. But these text strings don't parse as numbers, so they show up as red. So we kind of get an indication there. And similarly, over in this column, the gray represents missing values, so empty cells. So I click this, and it gives me some things I could do with missing values. I could delete those, or I could copy values, or do a different type of interpolation to fill it in. Look at that. Now I'm getting pretty close to cleaned up data, but I still have these extraneous rows here. So I could click this and just delete these ones with the text. But that could be an error. Maybe I have things that don't parse, but I don't want to delete. So I can give it more specifically what it is I'd like to remove. So in this case, I say get rid of the rows that have the text reported crime in. And it doesn't immediately show up as a suggestion here, so I can give it a push. We have a standard menu-based UI as well that gives access to all the underlying commands. So then if I choose delete, it will update the types of suggestions. I can see this is right. And now my data is in a format. I might want to rename these columns, but then I could export this and use this in a database, for example. So if I wanted to do that, I could then click export. And you see that before I do, I actually have the entire history of what I've done here. So I could actually review each of the steps that transform the data. I could even modify those if I wanted to. I can go in and actually change parameters interactively or view the space of all possible parameters for an operation. In this case, I'll go straight to export. And I might do this in comma-separated values for Excel, do JSON data, for example, for web-based visualizations. I have lots of options on how to export that data. But now let's say instead of having a full data set, I just put in a subsample of a much larger data set. Maybe back on my hard drive, I have millions of rows of data. So instead of export the data, what I've done in this process is not just transform that data instance. I've created this transformation script. I've written a program. So I could, in this case, actually just export the Python code that I could then just run to clean my entire data file. And of course, I can do this in other languages as well. And so this is one of the ideas that we wanted to make data cleaning more accessible by creating a user interface that allows people to explore the space of transforms and then easily evaluate their outputs, and then take that resulting program and perhaps run it somewhere outside of the browser. So that's sort of the demo of the data wrangler system. Just a couple notes on what's going on behind the hood here is that what we started with this project is we talked to a lot of colleagues in databases. Say, well, how do you go about the problem of data cleaning? Turns out there was a lot of prior work in creating languages for exactly this task. So we looked at that and we expanded it based on a corpus of data sets and tried to figure out, well, what are the sets of operations necessary to really rapidly clean data? And then we thought about, well, how can we build the user interface that goes with that? And we initially started by saying, well, can we come up with direct gestures that map to statements in this language? And it turns out as we tried to do that, most of the simple types of gestures like clicks and text selection, et cetera, just turned out to be too ambiguous. It just mapped to multiple possible transforms. So what we ended up doing is take what we call a mixed initiative approach. And this is coming from the HCI research literature. And that as the user interacts with the data, the system might make interactive suggestions on what they might do next. And so as people select elements of interest, we try and suggest applicable transforms. And to really make this dialogue smooth, provide these means for previewing the effects and the refinement. So then we wanted to see how well this played out in practice. So we compared Wrangler performance to Excel on a set of representative tasks. And we found that this was a very small data set intentionally to make it a more fair comparison, and that even with very small data, maybe 30 elements, median completion time for Wrangler was at least twice as fast. And one of the things that really excited us was that skilled Excel users benefited proportionately. So even people who knew like the advanced macros or options in Excel, they saw similar benefits when they used Wrangler. They were sped up by the same margin, which meant really that their knowledge of data allowed them, again, to be faster than novices, but the tool wasn't standing in their way. Their knowledge was actually transferring to this new tool. And so this is just one example of a type of problem we'd like to address in this larger life cycle, in this case by using some of the visual and interactive techniques along with maybe more formal languages from databases to really accelerate our ability to deal with data. Now, of course, in the center of this diagram, it's no mistake I've placed visualization. So in addition to, in this case, data cleaning, a lot of the work in our research group is on novel visualization techniques or novel frameworks for creating visualizations. And so I think it's useful to think about, well, if we think visualizations are valuable, what are the ways that most people create them today? And so think about that. What's the most common way you think people create visualizations? All right, so I heard a lot of people say Excel, among other things. And so, yeah, the most common thing is you don't really create a visualization, you just select one from a set of templates, right? And so in statistical literature, we refer to this as a chart typology. As you pick from a set of stock templates, they're easy to use, but they have limited expressiveness. So as soon as you have a data type that's not supported, or you have a visual design idea that's not easy to configure in these, the system breaks down. It's really not a creative process so much as one of selection. And so for years within the visualization community, people have tried to devise frameworks and toolkits that provide more expressivity. There's like a wider range of custom visualization designs. And so the most common approach, and this is true in both scientific and information visualization, is what I refer to as a component model architecture, which is, well, can we abstract what's common to the visualization process, maybe make operators or transforms that do that, and then allow people to string those together in novel ways. So if the first example on the left is Mad Libs, if you will, like form letters, these are basically templates through which you punch your data. On the right, we've graduated to Legos, where we have a bunch of blocks that we put together. Of course, these are actually blocks that have hundreds of buttons and knobs on the side of them as we have to configure what these various transforms, in this case, say a pipeline for defining a visualization might do. And this is a bit unfortunate if you think of this from a design perspective, because you really have to think abstractly. What are these high-level abstract operators by which you would transform data to result in this visualization? Where it would seem perhaps more amenable if I could talk directly about the graphical marks themselves. And so it was this idea of basically trying to invert this process that led us to one of our recent projects called ProtoViz. Before I do that, I want to motivate it a little bit. We actually kind of took some inspiration from the past. This is from the famous statistician John Tukey, who wrote back in 1962 that today's first task is not to invent wholly new graphical techniques, though these are needed. Rather, we need most vitally to recognize and reorganize the essential of the old techniques, to make easy their assembly in new ways, and to modify their external appearances to fit the new opportunities. So while it's important, I think, maybe to think about maybe novel and interesting visualization techniques, I think really what Tukey was getting at is that we really already have a basic lexicon of visualization techniques. The previous talk already talked about visual variables, which is one thing. We have a whole sort of things such as position, size, shape, and color that underline many different visualizations. Can we just speak more directly in terms of those things and allow unique combinations of those basic techniques? And so that led us to develop a system we call ProtoViz, which is a declarative language for visualization design. And the basic idea is quite simple. It's just a realization that a complex visualization, such in this case this radial bar chart, that perhaps not the best example of visualization design, but it's interesting, was designed in the 1950s by a graphic designer to communicate antibiotic effectiveness information back when they were the new wonder drug. Take something like this that maybe is a bit exotic by Excel standards. What makes it up? Well, it's really just a combination of a bunch of constituent marks, each of which are driven by data. So each one of these different bars represents a data element. This represents a categorical variable by which the data has been grouped. And then we have things like grid lines that provide a framework for this. So can we really just make simple statements about data mapping to these visual marks by which we can compose more interesting visualizations? So that was the idea. And so to do that, we first to say, well, what are the graphical marks we should support? So since we're designing a language, we should ask, what are the primitives of a visualization language? And we actually ended up settling on just 8 basic types, and it turns out that these were sufficient for a wide range of visualization designs. So things like areas, bars, which in this case are just rectangles, plotting symbols, which we call dots, which can take on various shapes, raster images, lines, which you might close to form polygons, labels for text, grid lines are convenient to use, we called rules, and then also angular wedges. And so we built a large variety of examples, and it turns out these were sufficient for quite an expressive range of visualizations. So then the question was, how do we take these basic types and put them into practice in an easy way? And so here's an example for just a simple bar chart. And so what you see is this case, this is actually the syntax. The language is implemented in JavaScript and uses HTML5. So the output is actually scalable vector graphics. So this is visualizations that work directly in the web browser. And so what you're seeing here is that we have a visualization. We tell it that we want to, say, add bar marks, that's these rectangles, driven by this data set. In this case, it's just an array of numbers, but any arbitrary data can work. And then we just set the visual properties, some of which are constants, and some of which are functions either of the underlying data or just its index in a list. And I don't want to go into great detail about the syntax and the design here. You can look this up online. But conceptually, what we've done is try to create a system that's basically cascading style sheets for data. So you have data that comes in, you pick a mark type, and then you're just styling that data with a set of visual properties. And then the only real difference from cascading style sheets here is that the properties aren't just constants, but they can be functions of the data itself. And so by doing this, you can directly sculpt the visualization by writing the visual properties in terms of the data. And so the next question you'd ask is, by having this, well, okay, that's great. You showed me 5 rectangles on the screen. That's really exciting, Jeff. Can you do interesting things with this? And the real power is that through composing these and also through some shorthands we did with inheritance, you can make this scale rapidly to really interesting visualizations. So for example, if you wanted to create what Edward Tufte is referred to as perhaps the greatest statistical graphic of all time, this, of course, Minard's depiction of Napoleon's march on Moscow, you can do that in under a page of specification. About a half page of code, and you can build these things up. So I think, again, really the power is in composition, just like it is in all languages. So we've done this to generate a lot of different visualizations in different domains, but the really exciting part has been seeing what other people do once we put this out into the wild. So for example, here's a visualization of MIDI files that was done by a music student, not a computer science student, showing different representations, here in this case of the frequency of notes in MIDI. And because it's web-based, it makes it much more easier to mash up with any other technology that works in the browser. So in this case, being able to embed a play widget for the song itself and actually synchronize the music and the visuals together. And so this is the type of projects that students are able to do, not necessarily with a complete computer science background. So we found that pretty exciting. Other examples include other diverse types of visualizations. So here's a Dorling cartogram, a particular type of map. So this is actually showing data about the US population. In this case, the size of a circle is the number of people living in that state. And the color indicates BMI, body mass index. So this is basically a color map of how fat we are as a nation. And you might say, hey, we're doing great. Look, it's green. California, we're maybe around 15%. I mean, Indiana isn't maybe trending poorly. That might be worrisome. However, this data is from 1995. You're laughing now. It's actually really not funny. Where, for example, in parts of the Deep South, it's now over a third of all people have a body mass index, which is technically considered obese. And so these visualizations, what we've been excited to see, while this one's particularly sobering, it provides interesting ways of communicating this data, hopefully in ways that might make impact. And so we've been happy to see, for example, these tools be picked up and used at places such as the Washington Post and the BBC to help create visuals as part of their journalism. But I would argue for anyone out there who's a toolkit builder, probably had a similar experience. The really most, I think, engaging and rewarding part of this is when people do things with your tools that you didn't even know was possible. And so, for example, I did not know a priori that it would be possible for someone to take this and reproduce Buckminster Fuller's Dymaxion maps. So in this case, if you're not familiar, this is actually a particular geographic projection that takes the sphere of the world, projects it on an icosahedron, and then just folds out the sides of that polyhedra to create different projections that actually have really wonderful area-preserving properties. And so being able to see people creatively create or recreate, as the case may be, different visualizations has been really exciting. And then along the same line, here's one that was done by a user that I found really cute. This is called Flickr Season. And what it is a histogram looking at the frequency of tags on Flickr. So in this case, it's set to the view to show months. So this is months of the year, January around to December. And then you can see the prevalence of photos with particular tags at those times. So given this image, does anyone want to wager a guess as to what the tags are? What do you think the query was to generate this view? Okay, so people take big holidays right before Halloween? No, okay. This is an obscure one. I will buy a beer to anyone who gets it right. Ooh, babies. I don't know what the answer is for that. I'd love to type it in and find out. So one of the ways I do this is I learn new queries for me to go back and type in after my talks each time, which, to be honest, is the real reason I asked the question. No, this case is actually California wildfires. And what's lovely about this, I just showed the example of the visualization. It then provides an index into those photos as well. So it actually provides a really interesting context. In this case, what shows up is somewhat dependent on the creativity of the person typing into it. But again, we've seen a wide variety of visualizations that have been enabled using this declarative language. And again, runs all in the web browser without plugins. So, part of the research here was exploring the language design itself. And you can go to our website to see more details about that. I just wanted to say a few notes about the approach we took, both in terms of this mark-based approach, so creating visualizations by making statements directly about the marks, so you can reason about the things that you're seeing on the screen as part of your visualization design process, rather than in contrast to my own prior work, which involves a much more abstracted approach. And so we think that's a benefit. Plus, having this nice declarative specification provides a number of benefits, including that we've done some studies showing this has led to faster designs and less code. So we do studies where we re-implement visualizations that have been done in prior work. And for example, in just one example here, it took 5 times less code and 10 times less development time using this language. And so while not everyone always thinks of programming languages in the framework of human-computer interaction, I think it's really useful to think about what are the aspects of your language design and how do those map to the way people think about their problems. I think this has helped contribute to the fact that it's seen a pretty wide uptake. But there's also some interesting things we can do. By picking a declarative model for the language, we can explore implementations of this language in different frameworks. And our primary flagship version is in JavaScript. But for research purposes, we saw, well, what happens if we take this out of the browser, where obviously we have a lot of limitations on what we can do in terms of performance or the types of things we can program. So we took it into Java to see what we could do in an implementation there. And one of the things we looked at was, one of those nice approaches is not only do we think we can build a language that's easier for people to use, we can take advantage of this declarative specification, so much in the way that a database takes an SQL query, does all sorts of query optimization to try and make that run fast. We can do a similar thing for how we process and render the visualization. And so in our Java system, we've explored different approaches here that allow us to visualize data sets that are 20 times bigger than what the previous state-of-the-art tools we could do, because we can let the programmers do what they do best, let the designers and developers focus on the domain, and not force the designer to also be the software engineer that tries to make everything work well. And certainly, as when I switch into the mode of designing visualizations, I appreciate that. And so I'm going to wrap up this part of the talk, but I just wanted to leave you with a teaser, which is we spent a number of years developing ProtoViz, but along the way, we've also learned something of its shortcomings. And I'll let you find that out for yourself, but let you know that my student, Mike Bostock, just released a new framework called D3, called Data-Driven Documents. So if you're interested in getting your hands dirty in scalable, interactive visualization in the web browser, I encourage you to take a look. And just as a teaser to whet your appetite, I would describe D3 as if jQuery and ProtoViz had a one-night stand, then D3 is the prodigy that resulted of that union. So I encourage you to take a look. So that's a description just of some of the work we're doing in visualization, and this is really a focus on tools. We also do research as well on novel visualization techniques, but in the interest of time, I'm going to skip that for now, because I think there's something more important to talk about, which is once you have the visualization, what happens to it? What is the social life of visualization? I think anyone who's designed a visualization, what's the first thing you want to do is show it to somebody else. And then usually the reason why is because there's something interesting. There's a story, and there are multiple stories to tell, and you're engaged in discussion around it. And so how did these items, like the social life of visualizations, affect analysis? And this was a question that we continue to be interested in. I've actually been looking at for a number of years. And the question of collaborative data analysis with visualization was actually the subject of my thesis back at. And I'll share with you one project in this space, which is work I did at IBM Research with my colleagues Martin Wattenberg and Fernando Villegas at Google. And we built a system called Census, or Sense.us, which is a system for collaborative visualization of demographic data. So one, we wanted to pick an interesting data set, which in this case was 150 years of United States Census data. And we wanted to explore, well, if you take visualizations, but you start adding social collaborative features, how does that affect the analysis process, particularly in its early exploratory phases? And so I'll show you a demo of that system now. So first there was a splash page, and we had a curated set of data sets and associated visualizations. And the real interesting part from our research was the set of social facilities we included as well. So let's take a look at that. So this is one of the visualizations we included in the system, and it's called the Job Voyager. So what you're seeing is called a stacked graph. For those of you who saw Martin's beautiful work, The Baby Named Voyager, this was inspired by that. So the fact that I was working with him, it was no accident. It led us to this design. What you're seeing is the occupations of American workers normalized over 150 years. So if you see here, we have farmers are almost half of the population, or like 40% back in 1850, and have greatly dwindled here. And you can see other jobs as well. And in this case, it's broken down by gender. So we've separated male and female. So one of the things we can do with this visualization is dive in to see a pattern more clearly. So if I click farmers, it'll zoom in on that. And I can see much more precipitously the drop from farming being almost the plurality of occupations to very, very little. Of course, what you probably also noticed is that when I did this comment appeared on the right. And the comment says, "There's no arbitrary division of labor between men and women on a farm. Unless there are millions of bachelor farmers, these numbers have more to do with the prejudices of the folks in charge of the data than with the populations of American farms." And so you might agree or disagree with a commenter, but they're making an argument that this smaller stack down here, which represents female farmers, may not be representative. Maybe they're counting heads of household, for example. So one of the cool things that we saw was it's not just people talking about the data, but realizing that data is a product derived by people. And that there are all sorts of interesting intricacies that go behind where does data come from, how was it collected, what were the categories, et cetera. And these types of deliberations that affect how you interpret the data were one of the hallmarks of the types of things we saw by allowing this type of commentary. So let's look at some other quick examples. I can go back to this overview. In addition, I might filter by gender. So by doing this, for example, I more clearly see that dramatic rise of women in the labor force that occurred after World War II. And this, of course, led to some conversation. In this case, a person comments on it and also used graphical annotation techniques to highlight exactly the trend that they're talking about. And this sparked some conversation. For example, one person noted, well, yes, if you look at household worker, it seems to be the opposite trend. So a lot of times, interesting observations would spark responses. Let's look at another example. One other way we can explore this data is just by entering in queries. So for example, if I type the letter B, I get all jobs that have a word that begin with the letter B. So I have my beauticians, barbers, bookkeepers, bank tellers, et cetera. But what I want you to notice is that when I type this, I also updated the URL location bar up here. And while maybe a seemingly simple or a relatively easy design decision, this turned out to be absolutely critical. Because at any moment, the state of the application was reflected there in an easy to understand way that allowed people then put that into IMs, blog posts, nowadays it would be tweets, et cetera, so that someone else could come and see the exact same thing, providing the common ground for a conversation. So for example, I can keep typing, and as I do so, that bar updates. And then I can arrive on what turns out to be my particularly favorite view within the system, which is American bartenders. And so for all my talk of data cleaning earlier, you definitely need nuanced human judgment here, because in most cases, a dip like this would suggest missing data, where in this case, there may be a reason no one admits to being a bartender in 1930. And of course, interestingly enough, commenters note that afterwards is when you see a rise in female bartending as well. So let's look at one last example here. So that's waiters. And one of the reasons I like this is that I'm not talking a lot about visualization design, but one of the things we care about deeply, both in my classes and our research, is how do different choice of visual variables affect perception? Obviously, that's some of the bread and butter of visualization work. And so it wouldn't be fair if I didn't point out some of the weaknesses in the visualization technique we picked here, which while stacked graphs are great for showing aggregates and sort of afford this neat animated filtering techniques, they also have drawbacks. And so it might not be immediately apparent by looking at this chart what's happening with males, because it's biased by the stack of females underneath. So for example, if I filter to see just men, you realize there's actually a very interesting and significant dip in the number of male waiters in the second half of the 1900s. So that might be interesting. What's happening here? So let's add a comment. So we might ask why the dip in males, and if we're conscientious, we can even point to it. There may be more than one dip, very common. So any hypotheses as to what's happening here? Okay. All right, war. What happened? Say there was war. People said Vietnam. I believe we also have Korea, etc. I've given this demo so many times, that's the first time I've heard astronaut. So that's 2 firsts in one night. This is great. Someone else said fast food. That's interesting. Anyone want to elaborate more why fast food would decline the male population of waiters? Okay, so usually the argument would be fewer overall waiters. So one of the things that's really helpful in these is when people, they further explicate their reasoning and their hypotheses, and we saw a lot of that. One other thing that has been suggested to me by colleagues in social science is what they called feminization, which is a fancier way of saying that the perceived gender role may have changed. So if you saw that there was a large influx of waitresses, did that change how the job was perceived? So that's another hypothesis you might do. And one of the things that was really fun about launching the system is people would make these observations and then make hypotheses. Most people were quite modest, so they framed their hypotheses as questions, which is an interesting linguistic thing. But so here's just one example. So let's just save this for now. And let's say we wanted to up the chances that people might find this interesting set of questions and respond to it. Well, one of the things we provided was the ability to, one, save trails or histories of views. For example, I can now save this view for revisitation down here. But it also allows us to engage in some linking behaviors. So if I go back here, I can say, plant a signpost and really say, don't miss the dip in males here. And then I can drag and drop this and start creating links. I could change the link text, but to be quick, I won't. So you submit this, and then now I have this signpost planted here in the user interface that might bring someone to that view. And then so assume for a moment I'm someone else. I might come to this, and then I can start to evaluate some of those hypotheses. Like, the fact that there was military service at the time certainly seems like a reasonable hypothesis. So how might I start to test that? Well, one, I can start mixing up the data in different ways. And while not a perfect visualization, this is enough for us to see that the rise in the military buildup, yes, this is the picture of the Cold War right here, does seem to coincide with the decreases and increases of waiters here. And so we don't have rock solid evidence, but we've already started to advance an argument in a data-driven way. So this is all about exploration and with social features in the visualization itself. Of course, we might want to look at it other ways. We can search through what everyone else has said. Maybe we have a topic of interest. Well, I've only been at Stanford for about 2 years, so I really want to know what's happening with disappearing professors. And so we come here, and this is actually an interesting area in which people note problems with the data schema. So it turns out the level of detail that's available in different census years varies. So I have professor as a general category, and few, that's going up. But I can look at some of the others, and I can see that we have subdisciplines, professor of social science or mathematics, et cetera, in here. And the commenter points out that there was higher granularity in the data, and then it's gone away. And again, we saw many of these types of comments where people were helping others make sense of what might seem to be odd variations in the underlying data. So with that, I'll jump back to the slides and share a little bit about what we learned deploying this. So we did different deployments. Unfortunately, I couldn't do a live public deployment because this was done while I was working with IBM. What we did do is do a set of laboratory studies where we'd bring someone in to use it, and then we'd have other people just build on that. Then we'd reset the system and basically launch it again and see what happens. And then we did do a live deployment, but it was within the IBM intranet. So we still had thousands of users, but we didn't have access to the wide, woolly web. But we did see some interesting patterns of usage as a result of these deployments. So some involved people pointing out trends of interest, oftentimes trying to bring in external data, like building up timelines was a common thing. And in this case, the person got a little anxious and maybe submitted it before they put in the label for World War II. So what we saw was a lot of people building on top of each other. So you could build not just in terms of text comments, but in terms of annotations. So someone else came in and then added their own comment where they fleshed out an annotation further. In this case, many people were interested in the pattern around US military buildup. Other people told jokes while they made comments. So here the comment title was "The Great Depression Killed a Lot of Brokers." And so we have a suicidal broker conveniently jumping down to the trend of interest here. Though I have to admit, as much as this made me chuckle, it was the dramatic increase in stockbrokers from 1980 onwards that actually really caught my intellectual attention. Other things, the great postmaster scourge of 1910, or just a bug in the data. So opening up the data public scrutiny in an accessible way, as you might imagine, revealed lots and lots of potential data cleaning errors or bugs in the data. And again, finding these quality issues was something that this sort of crowdsourced exploratory analysis was quite good for. But far and away, my favorite examples involve people really engaging in a collaborative analysis project, what we call collaborative sense making. And this one surprised me because this was actually a seed comment that I put in the data. So every time we rebooted the system, there were 5 comments that I had just put in as seeds, as basically examples of the type of behavior one might engage in on the site. And this was just, where did all the dentists go? So you see a peak in male dentistry as a percentage of the population in 1930 and a subsequent drop-off. Little did I know this would become a topic of much debate and discussion. So for example, people would again start to bring in outside knowledge, like here's where we started fluoridating the water supply. I wonder if that had an effect. But then a question, what's happening with this bump? Why would there be a resurgence here? And there was a mix of both evidence and anecdote. People would tell stories from their own lives, like I went to the dentist once a year when I was a kid, but my kids have to go twice a year. Is this some kind of scam? What's going on? But by far and away, the most interesting examples were ones that use data to speak to data. So in this case, someone thought about it and zoomed out and said, well, let's have a view that includes dentists along with technicians, so hygienists. And instead what you see is that dentistry hasn't declined, rather it's continued to increase as a percentage of the population, but it's stratified. That what might have been a single profession before is split into different classes, where now you have dentists, and hygienists. And this was a hypothesis the person made by looking at this view, and that led others to go outside the site to look for corroborating data. So people actually found the median salaries of dentists and showed that indeed they were going up over that same period, thus trying to collaborate and figure out what was happening in this trend. And while it doesn't, again, provide proof, you'd actually want a statistician to engage in confirmatory data analysis. We were very impressed by the ways in which a somewhat random group of people could dig through the data, highlight interesting things, and begin to explicate the various factors. And there's many other examples of this I don't have time to go into, but we've documented a number of them in our research papers. And so one of the funny things we saw here was also looking at different usage behaviors. So we saw that we can engage directly with the visualization, but we also had those comment listings you could go to. And we saw this basically taking up 2 complementary phases of analysis that we called voyagers and voyeurs. And so we refer to as voyagers as people when they're focused on the visualized data. So they're engaging with the visualization, usually tracking down their own pet hypotheses. So not surprisingly, what people would do is start by looking for themselves, whether that's them personally or their family members and friends. They'd look for those occupations that were near to them and then explore from there and then develop other pet hypotheses. And along the way, they'd respond to the social traces that were left by others. But eventually, everyone tired of this or ran out of ideas, and that's when we saw everyone that we observed switch to looking through the comment listings, and that's when they became what we called a voyeur. And this title came not because we were rude, but actually from a quote from one of our participants who said, "I feel like a data voyeur. I love looking at what other people have been searching for." And so people were motivated for this in different ways. So in some cases, they were just kind of, interested in what other people thought was interesting. In some cases, they had known colleagues had used the system, so they'd try and hunt them down and had their own psychological theories of what their colleagues would have searched for, or at least folk psychological. But interestingly enough, regardless of the motivations, in all cases we saw it catalyze new explorations, where people would find a comment they found interesting that took them back into the visualization and sort of re-engage them in this process of being a voyager. And so while qualitative, in every instance we observed, we saw this feedback loop by having this social activity data triggered and new explorations and analyses that probably otherwise wouldn't have occurred. And we've done a number of follow-up studies that have shown some interesting results along these lines. So for example, if you include what we call information sent, borrowing from the theories here at Park, of where other people have been in the system, we find that having a global overview of where people have been has really interesting effects. And that, as you'd expect, people are likely to go look at really popular views because they want to know what's going on. But by seeing areas of the data that haven't been visited, we found that it actually, people preferentially allocated their attention to the parts of the data that hadn't been seen yet. So you actually got broader coverage by also exposing where people had looked across the database. This has led to a number of other systems, the most prominent of which, Martin and Fernanda, my colleagues then at IBM, released a system called Many Eyes, which is similarly a system designed to support social data analysis. And they had interesting findings as well, particularly that once you open this up and you have many, many, many people creating a large number of visualizations, it's much harder to have the type of sustained conversations we saw in our system, where we really curated a data set and try to funnel people in to looking at the same data. Instead, what we saw in the usage here is that people would create visualizations and then embed them in their own blogs. And that's where these similar types of social analysis activities were occurring. That basically, in this case, instead of having the walled garden, taking the visualization back to your existing communities in the existing social media frameworks that they already had people paying attention to, subscribing to, et cetera. So I think any of these systems, obviously, it probably goes without saying, need to take the ecology of the web into account when thinking about how these different social interactions will occur. And finally, just a few notes. We actually did some more formal analyses. Not surprisingly, most comments involved observations, followed by questions and hypotheses. But interestingly enough, that was most of the conversation. We saw these cycles where questions would result in other people providing their hypotheses, and people would engage in conversation. But again, 16% of usage of our system and 10% on many eyes involves data integrity issues. So people pointing out problems, either there's missing data, there's errors in the data, or we shouldn't trust how this was collected. And so what's interesting is that here we're at the far end of this pipeline I've drawn. We've gone from data acquisition all the way to visualizations published on the web, and it's still providing those same insights back into earlier parts of this process. And so thinking again about the various ways in which user interfaces better facilitate the highly iterative nature of sense making, I think, will remain a fun and interesting research challenge in the years to come. So with that, I just note I have a number of really wonderful students and collaborators who've helped with these projects. And if you're interested in knowing more, this is just a small sample of the projects we're working on at Stanford. I encourage you to visit our website at viz.stanford.edu, where you can see kind of the full spectrum of things that we're working on. So with that, I'd like to thank you all for your attention, and I'm happy to field any questions you might have.
So while you're doing this visualization, do you also research how people can use it to their advantage? Like, this is the truth, but they really want to see this. How can they move that data from what they have to what they want to show? Or you don't really do that?
No, I think that goes kind of counter my own philosophy. So there's two different things. So one is, we don't create tools so that people manipulate the data such that it tells the story that they want to tell, regardless of its truth. Now, people do that, and they do that regularly. And to think that our tools will stop that would be foolish. Though certainly the tools we develop, it's about making data useful. And I think what is really valuable is providing the ability to take data, one, visualize it in many different representations. And so that's part of what we're trying to enable with our tools, is that one particular representation of that data may highlight a set of features that tell a specific story, but the ability then to manipulate that and see it through a different perspective or a different visual representation is very useful. And that's at the visualization end. At the data end, you'll notice that one of the main things about that data wrangling system I showed first is that it's not really, at the end of the day, about transforming the data. That's a byproduct. What it's really about is creating the script that transforms the data and preserving that script in the way that you then have access to the data provenance. And we would love to see those transformation scripts. I think should be the types of things that should be published with the data sets themselves to allow people to inspect for themselves whether or not they agree with the transformations that have been done. Now, granted, I think it's very few people who will dig that deep, but maybe the 1 or 2% of people who do, I think, have an incredible impact on society quite often. So, yeah, there's a question over here.
Looping back to the issue of data cleaning, there are certainly lots of files floating around in the world that look messy.
Yeah.
So if you're trying to run them through Excel, they don't run, they won't budge. But that noise is also information. So it carries a lot of information about the schema that data encodes. Mm-hmm. And I wonder if you've thought about, as it were, reverse engineering that noise, that mess, to try to recover the information structure, the schema from which that data was created, the sort of reverse engineering of that.
Yeah, so interesting question. So I think in general that's certainly very difficult, not impossible to do in an automated way. I think one of the things we want to do is make data more malleable so people can make those modeling decisions. And there's not just one right data model, and it also is depending on what tools you want to use downstream depends on what model is right. Now, in the types of transformations I described, oftentimes data gets thrown away. It might be a title row that doesn't fit the data model but is actually useful information. Many times you'll see spreadsheets that have annotations at the bottom, and it's really useful. And we're aware of this. We haven't supported it yet, but I think one of the things that makes data really useful is not just that a downstream tool can import it without crashing, but also that a person can understand what do these variables mean. For example, like you might look at census data. In 1 year, the sampling was done differently. And what does that mean? Well, it might have impacts on your analysis. And so one of the things we are interested in is taking some of these notions of kind of social annotation that I talked about in the context of visualization, and also thinking about how those can be applied to the data sets itself. So how can people build up basically instruction manuals, guides, or annotations for specific, whether it's columns for particular variables, or even particular records of data, in a way where we can have the data in a format that's amenable to lots of the different visualization and analysis tools we'd like to use, but also holds on to that really interesting, like human annotations or other pieces of information that allow us to better judge, what the data is about and is it useful for our current purposes. Yeah, in the back.
Yeah, kind of going off the last two questions. I'm wondering if you guys have considered, I don't want to turn this into a brainstorm session, sorry, but like, I'm wondering if you guys have considered working on stuff, like augmented reality. I can hold up my iPhone. If someone's holding, CNN has charts and graphs and stuff thrown up, and they're sort of manipulating charts and stuff to meet their needs. Do you guys work with sort of augmented reality stuff? So I could hold it up and go, oh wait, they're totally skewing the data set, or things like that. I mean, if we're talking about data integrity, right, and being able to follow those paths and stuff, do you work at that level, or is it mostly in the language scripting for people who are creating the initial data sets?
Yeah, so it's an interesting question. So my group, we're not directly working on augmented reality. I think a lot of the things you see, like when like John King or Anderson Cooper holds up a card and then a big 3D pie chart shows up on the screen, that's certainly not the type of augmented reality that I think is that useful in terms of facilitating thoughtful analysis. I do think of cases where it can actually be quite useful, though, if I have, say, a physical map of a topological space. Like maybe I'm doing planning for environmental planning, and then I can project down on that lots of different layers of data and actually see it not in some sort of 3D model captured in the screen, but on the actual physical 3D thing. I can imagine instances like that being useful. We're not working on that directly. I have an entire rant on why 3D is probably bad for most visualization purposes, but I'll spare you that now. You can ask me afterwards if you want more details. Or you can come hang out in my class at Stanford.
Given that visualization is a relatively new invention compared to text or images, so do you think in the next 50 years, visualization will become a common language that people use to communicate, or will always be a niche that's used by few people?
Oh, that's a fantastic question. So one, I would push back just a little bit on your assertion that it's new. I actually gave a talk at Stanford a while back that's on the internets, if you want to see it, about a brief history of data visualization, and it's thousands of years old. Especially if you think of maps, which I do as an information visualization. Though that said, you're right in that modern statistical graphics is only a couple centuries old, really traced back to Playfair and folks like that. Is it becoming a language? I'd like to think so, or a language of sorts. I think it's one that has many different genres, just as text does. And I think quite frankly, I think it's already become a type of communication medium, and I don't see any signs of it stopping. And so one of the things that it's really a pleasure for me to do as a tool builder is to watch how people evolve that language in creative ways. So rather than try and say, this is the way it should be done, put the tools in people's hands to see what they come up with and how they evolve the medium, which has this nice coevolution effect, because then it gives us ideas on ways to do more expressive, interesting, and hopefully easier to use tools.
So I went to one of Edward Tufte's lovely, speeches, and he really kind of pushes removing as much of kind of the visual stuff as possible. I mean, spark lines to him, hundreds of spark lines on one page to be able to see everything is really what he thinks is the best thing. How much do you think is the right in between of having visual design to help kind of make the data important or more readable versus having just more data on the page or just, less getting in the way of the data, I guess?
So I will answer this with my favorite answer that I learned from my colleague Terry Winograd. It depends. No, so seriously, it's completely dependent on your goals. What's your purpose? Why are you creating the visualization? If your goal is to, if you have an analytic challenge, like I'm trying to understand the stock market, and to do that, I need to see X number of things. Can I fit more data on a display so I don't have to scroll, so I'm limited just by the ability of the saccades of my eyes to jump around, and I can make quick comparisons? Great, that's going to help me process data faster and hopefully come to conclusions or spot patterns I might not otherwise. And so I think Ed Tufte's had a number of great suggestions to try and help us do that. Now, if my goal is to convince you that we should or shouldn't say end state bargaining rights in Wisconsin, and I want to pull up data, I might be trying to tell a story. I might be trying to persuade. I may just hell, I just want to grab your attention first. And there's all sorts of visual design decisions. And so what you're trying to accomplish and what your goal is, I think, really depends on how you use visualization as a medium. And I think Tufte is best understood, and I don't want to be presumptuous, but I think it's best understood often in thinking about from an analytical perspective. And I think that's incredibly valuable. But as I think a number of great folks, including my colleagues Martin Fernanda, and also a really interesting work by folks like Aaron Koblin at Google show, like there's more to visualization than just analysis. And so I think where things get difficult is when projects try and straddle the space between some of these different goals, and I think that's where sometimes things go awry. But again, this is going to diverge into a very long conversation, so we could have this afterwards.
So maybe a question on sort of the flip side of that is, what do, in your experience, actually seeing a lot of users engage in a lot of these different, graphics, what do people walk away from feeling the best about? Is it seeing a large swath of data and being able to engage it? Do they step away from that saying, oh, I learned something?
Yeah.
Versus one solitary graphic that clearly has an intention sort of stated. This is the fact that you're supposed to understand.
Mm-hmm. Well, I think my response is going to be colored by my own emotional experiences, but it's when I learn something surprising. When it becomes apparent to me, like, oh, for example, even just the cute thing about California wildfires. Like, when I saw that, like, it was patterned and it actually, matched my own experiences to some degree, and that called me to reflect on different things, and it made me think about that topic in a new way. That's interesting. Also, when you explore a data set and you learn new things, there's many things I didn't show, for example, in that census data set. But all things like you can see when compulsory education was done, and what that does, you see the rate of teachers go up. Like you start to piece together some, in this case, narratives of American history through the data that are really interesting. And so far and away, I find that if you have great, stunning visuals, that will make people excited for about 30 seconds. And if they see through that, they basically stop thinking about the visuals and they start reasoning about what's happening in the underlying data. In general, that's the one kind of cue I look for, that you have a successful visualization. Yeah, sorry. Yeah.
Just question about, curious about some of the details. For example, is any limit to the data size, data set? And what's up about the scalability tests right now? Underneath support, is it file system or a database, particular relational or object database, and also about the performance? Just curious about these details.
So that's basically the entire syllabus for my class next quarter. So there's certain limitations of what you can do depending on the medium. Obviously, if you're doing hardware accelerated graphics, the number of things you can manipulate in terms of pixels on the screen changes versus what you can currently do in a web browser. Though let me tell you, you can do more in a web browser than you probably realize. So one is take a look at D3, my student system. It's really exciting. Just on the flip side, I think there's a lot of interest and very well-deserved interest in scalable data processing platforms. And that's everything from analytic databases like Greenplum or Aster to MapReduce, et cetera. But just to put that in context, I think we shouldn't undersell what we can do in the client. Just as one statistic, I've just written a pretty straightforward query processor that will do like group by style aggregate queries in the web browser over 1 million records in 50 milliseconds. And that's not doing anything rocket science. That's just with a little bit of thinking about how the browser tries to just-in-time compile JavaScript. So I think in terms of the types of applications we're going to be enabling in the web, like it's already here. Once IE9 hits the mainstream, and I hope it does, I think we're going to live in a really exciting place. Now, for massive data of the type I was talking about earlier, you're talking about terabytes or whatever, what you really have to think about is how do I transform that data? Not, it's pointless to try and visualize 1 billion points. Directly, it's just going to overwhelm human perception anyway. So you have to think about what are the data transformations that are appropriate to that data that then let me answer the question I have. And so that's usually where I think a big future area here is really in the intersection of these issues. So it's where visualization, statistics, human-computer interaction, and databases are going to come together. So it's going to require kind of a wide array of talents. But I think there's really interesting opportunities at that intersection to do systems that can really change how we work with data. Yeah. I have
user
yet.
Tools?
Yeah. Sorry. Well, I can say this has been a progression for me. So back in 04, 05, I released a framework called Prefuse, and that was written in Java. And that system co-evolved with the users who picked it up, who were software engineers in Java. And it served their needs, and that was great. And a lot of interesting things resulted from that, and researchers used it too. I then wanted to push it further, and so we built a kind of a variant of that in Flash called Flare. And it was fun to watch people who were, slightly more towards the space of web developers use it. But those of you who program in ActionScript 3 know it's now actually quite similar to Java or C#. And so what I actually saw was people were migrating from Java to Flash, and so was some of the same people. Protoviz was actually quite different. I'm seeing a much broader class of folks who I would primarily characterize as web developers. So there's still familiarity with JavaScript, HTML, and CSS is sort of like the buy-in you have to have, which is still, like, I think, a much, much larger audience, for example, than the space of Java programmers. And I've seen journalists start to pick it up, and that's been really exciting. There's obviously different levels of technical competence in different newsrooms, and so it's fun to watch that get picked up. I think part of what's made that successful is that we learned one of the things that for a toolkit to gain steam is give lots of examples that are easily manipulated, so that even if people don't have a complete mastery of the framework, they can pick up something and make it useful to them right away and get learning along the way. And so if they care to invest more, that investment pays off, and if they don't, they still got something useful right away. And so we try to design not just the language itself, but the supporting materials, including the examples, to help support those behaviors. And I think that's kind of an often undermentioned part of the design process for these types of tools. It's not just the tool itself, but really there's all the supporting materials that go along with it. That said, I don't know when it will happen, but our research goal is to see, can we move this more and more out of the domain of programming? And can we get more kind of directly interactive tools to create these kinds of visualizations is something I'd love to have students work on going down the road.
Great. Let's thank Jeff.
Thank you.